when stars 4 to 8 times as massive as the Sun explode in a violent supernova. Their outer layers can blow off in an often spectacular display, leaving behind a small, dense core that continues to collapse. Gravity presses the material in on itself so tightly that protons and electrons combine to make neutrons, yielding the name neutron stars. Neutron stars are the smallest and densest stars, excluding black holes, and hypothetical white holes, quark stars, and strange stars. They have a radius on the order of 10 km, 6.2 miles, and a mass about 1.4 solar mass. The gravitational field of the star is so huge that it significantly bends radiation from the star, in a process known as gravitational lensing, allowing astronomers to see some of the backside of the star. Once formed, they no longer actively generate heat and cool over time. However, they may still evolve further through collision or accretion. Most of the basic model for these objects imply that neutron stars are composed almost entirely of neutrons, subatomic particles with no net electrical charge and with slightly larger mass than protons. The electrons and protons present in normal matter combine to produce neutrons at such extreme conditions inside a neutron star. Neutron stars which are observed are very hot and typically have a surface temperature of around 600,000 K. They are so dense that a normal-sized matchbox containing neutron star material would have a weight of approximately 3 billion tons. Their magnetic fields are between 108 and 10^15 100 million to 1 quadrillion times stronger than Earth's magnetic field. The gravitational field at the neutron star's surface is about 10^11 200 billion times that of Earth's gravitational field. The power from the supernova that birthed it gives the star an extremely quick rotation, causing it to spin several times in a second. Neutron stars can spin as fast as 43,000 times per minute, gradually slowing over time. The fastest spinning neutron star known is PSR J1748-2446ad, rotating at a rate of 716 times a second or 43,000 revolutions per minute, giving a linear speed at the surface on the order of 0.24 c. Therefore, nearly a quarter the speed of light. Some neutron stars emit beams of electromagnetic radiation that make them detectable as pulsars. Indeed, the discovery of pulsars by Jocelyn, Burnell, and Antony Hewish in 1967 was the first observational suggestion that neutron stars exist. There are thought to be around 100 million neutron stars in the Milky Way, a figure obtained by estimating the number of stars that have undergone supernova explosions. However, most are old and cold and radiate very little. Most neutron stars that have been detected occur only in certain situations in which they do radiate, such as if they are a pulsar or part of a binary system. Talking of binary system, if a neutron star is part of a binary system that survived the deadly blast from its supernova, or if it captured a passing companion, things can get even more interesting. If the second star is less massive than the former one, it pulls mass from its companion into a Roche lobe, a balloon-like cloud of material that orbits the neutron star. Companion stars up to 10 times the Sun's mass create similar Roche lobe that are more unstable and don't last long. Stars more than 10 times as massive as the Sun transfer material in the form of stellar wind. The material flows along the magnetic poles of the neutron star, creating X-ray pulsations as it is heated. By 2010, approximately 1,800 pulsars had been identified through radio detection, with another 70 found by gamma rays. Some pulsars even have planets orbiting them. Neutron stars are very fascinating objects and that cannot be explained in one video. Speaking of them, there are different types of neutron stars and some really cool mysteries that deserves their own video. Okay, what do you think of neutron stars? If you think they are fascinating, give us a like. Also, don't forget to subscribe and click the bell button to be notified of further updates from our channel. Thanks for watching.